So now sample, just an example of determining the strength of the concrete sample in megapascals. That's the unit we're looking to get to. And again, we're going to use our sample 1-1 as our example. So sample 1-1, we want our strength of our concrete, and our units megapascals. That's what we're looking for. That's the standard unit. And just again to put in brackets, this is after 7 days of curing. And just kind of some conceptual things. 1 Pascal, it's a unit of pressure, and it's the pressure that is created when a force of 1 Newton is projected on an area of 1 square meter. So if we drew a cube maybe that was 1 meter by 1 meter by 1 meter, and we applied a 1 Newton force on top of it pushing down, and this was area of 1 square meter, that would produce a pressure of 1 Pascal. Now we're talking megapascals. Mega is 10 to the 6, so 1 million pascals, and that's our typical standard unit for testing the strength of concrete. Pounds per square inch is the equivalent unit in the imperial system, but we're using metric, which is pascals. So the other concept is strength is in pascals, which is a pressure. So strength, or stress, and pressure are congruent and equivalent type units. So the pressure, it's equal to the force divided by the area. And in our case, we have a cylinder, and the area that the force is being distributed upon, we're loading it axially, is that area of that circle. So that's going to be the force divided by pi r squared. And as we did in the last example, we measured the diameter, so we want to get this in terms of the diameter. So pi d squared over 4 is the same as pi r squared. So again, diameter is the radius is the diameter squared, or the radius is the diameter divided by 2. When we square that, we have to square both the diameter and the 2, so we get the 4, flip the 4 to the top. And this is our all-encompassing end formula there that we're going to use. And our sample 1-1 data that we gathered, the diameter was 102.85 millimeters, and our force was 146.27 kilonewtons. That's the force that the compression testing machine pushed on the cylinder in order to break it. One thing I want to do here is I want to get to meters squared. So I'm going to cheat a little bit and convert this to meters right away. Just move the decimal place over 3 places, so 0.10285 meters. And now I can go to my formula, my line, and I'm going to put in my force first on the top. Actually, I can put the 4 first, so I don't forget it. I'm going to this formula. 4 times the force, which is 146.27 kilonewtons. And I'm going to divide it by pi, and then divide it by the diameter squared, which is 0.10285 meters squared. So I now have kilonewtons per meter squared. That's a kilopascal, so I'm going to just do my conversion here. 1 kilonewton per meter squared is equal to 1 kilopascal. And I want my answer in megapascals, so I have one more conversion to do. 1,000 kilopascals is equal to 1 megapascal. And now, if I look at all my units, I have my kilonewtons here cancel out. my meters squared cancel out, and my kilopascals cancel out, and I'm left with just megapascals. So in order to get my answer, I just multiply all my tops, divide all my bottoms on my calculator, and I end up with getting my strength of sample 1-1. When I multiply all that work out, comes to about 17.6 megapascals. And again, that is the strength of concrete sample 1-1 after 7 days of curing.